Saya tertinggal handphone pula. Sorry, I lupa pasal saya tertinggal handphone pula. Okay. Alright, so first of all, I would like to ask you about because last Thursday you tak ada kelas dengan I kan? Betul tak?
Betul.
Okay. So bila you nak buat replacement class ya? When can we do the replacement class? Okay, so this Thursday kelas you pukul berapa? Pukul 10. Khamis pagi selepas ataupun sebelum kelas ada kelas?
Ada.
Ada? Okay, so kita tengok macam mana. Sama ada we will do the replacement class through my recorded lecture ataupun macam mana lah. Tapi at the meantime, I nak minta siapa dalam kelas ni? Kelas rep? Siapa kelas rep? Tak ada kelas rep ni?
Untuk C5 saya.
Okay. So, lagi satu group? Min kan?
Yes, madam.
So, Jumaat ni mungkin dah tak lah. Semua orang pun nak bergerak balik kampung kan? Bila nak buat?
Before 2 PM maybe tak ada.
Bila besok?
Thursday.
Thursday 2 PM tak ada kelas?
2 PM tak ada. Sampai
Semua orang tak ada ke? Kelas lagi satu macam mana?
Untuk C5 esok ada pukul 2 sampai pukul 4.
No, hari Khamis.
Tak ada.
Maksudnya petang tak adalah. Khamis kan semua orang?
Madam, saya ada.
Berapa pula you ada kelas?
Hari Khamis pukul 2 tu ada.
Berapa you kelas?
Sampai pukul 4.
Okay, so kita buat kelas besok 12.1. Cuma besok 12 tak ada siapa ada kelas kan?
Esok C5 ada kelas. Pukul 11.
12.1.
11 sampai pukul 1.
Hari Khamis?
Hari Khamis sampai pukul 12 je.
Okay, kalau macam tu hari Khamis 12.1 lah.
Madam, saya ada kelas pukul 11.1 hari Khamis.
Besok?
Besok tak ada.
12.1 besok. Besok siapa 12.1? Besok ada kelas kan 12.1? You all yang lain?
Ada doktor.
So, okay, kalau macam tu starting after raya kita akan start kelas pukul masuk Zuhur pukul berapa? Masuk Zuhur? Lepas raya hari Jumaat. Okay, hari Jumaat kita akan buat kelas ganti daripada pukul 8 sampai pukul 9 lah. So Jumaat tak siapa pun ada kelas kan? After raya.
ada.
Okay, so after raya 8 to 9. So teringatkan I, terus dua-dua kelas rep remind me after raya 8 to 9. Okay,
Okay,
so I think tak ada masalah dah kan? Alright. Okay, so kat mana kita stop hari tu? Masih lagi section pertama ke? Hmm? Hello? Kat mana kita hari tu?
Hari tu punya dah habis lah.
Dekat mana? Okay, is Hafiz kat mana?
Kalau ikutkan hari tu dah habis lah yang PDF tu.
Dah habis dah. Maksudnya, untuk adakah kita sekarang boleh masuk kepada motion of several particles?
Baru nak masuk baru nak start.
Okay. Oh, nak start. Alright, okay. So, basically we are completely done for the... Ya, betul lah tu. Okay. So, this week, patutnya kita dah habis lah untuk motion of several particles. Okay, sebab you tak ada kelas last week and then kita pun sebenarnya dah drag a little bit. Okay. So, let's we quickly focus on this one. On the second section on the topic 1, kita ada 3 section. Okay, first section we focus on the rectilinear motion of a particle. Now we want to study about the motion of several particles. Okay. So motion of several particle bermaksud motion yang mana kita fokus kepada more than one particle. Okay, so for this case, when we talk about motion of several particle, it can be divided into two, okay, which are independent and dependent motion. So before we go into detail, let we look first the learning outcome for this topic. Okay, you should be able to determine the rectilinear motion of a particle. You should be able to determine the motion of more than one particle at the same time, and then you should be able to relate positions, velocities, and acceleration of particle undergoing dependent motions. Okay. So before we go further into the motion of several particles, let's we look back on the two common types of motions, okay, of motion of the particles. Okay, bila kita study for the individual particle, it can be divided into 3 types sebenarnya, sama ada they undergo with constant accelerations, constant velocity, ataupun they undergo with the acceleration at any time t. Okay, so basically what we have done on the first part of the topic 1, kita fokus kepada determinations of the velocity or acceleration at any time t. Okay, yang mana kita akan menggunakan equations velocity ataupun function velocity, function acceleration or functions of positions untuk kita study about motions. Yang mana function tu kita derive daripada kinematic relationship. Okay, but when we are dealing with the constant velocity or constant accelerations, so this integration or differentiations is not involved at all. Okay, we can directly use kinematic equations instead. Okay, yang mana, for example, if you are talking about constant velocity, okay, you should understand that they are moving with constant velocity, it will produce zero acceleration. Okay, bila you punya velocity is constant, bermaksud you punya acceleration adalah zero sebab tak ada perubahan in velocity. So bila ini berlaku, bermaksud your particle undergo uniform rectilinear motions. Okay, dia bergerak dengan uniform rectilinear motions where in order to analyze a particle that undergo with this type of motions, you are not required to do differentiations or integrations. Okay, you can just directly apply this kinematic equation. Yang mana basically this kinematic equation has been derived from this process. Okay, cumanya apabila dia melibatkan constant velocity and zero accelerations, you tak perlu nak go through dengan yang ini, yang mana dia ada standard equation that you can use. Okay, so when involved with this type of situations, okay, you cuma ada satu equation sahaja yang you boleh guna untuk nak study about dia punya geometry of motions, which is in this case you can identify the positions of the velocity only, because in this case the acceleration is equal to zero. Okay, and if your acceleration is constant, okay, if your acceleration is constant, So you may have 3 kinematic equation to be used to solve for the problem. Okay, kalau sebelum ni kita ada these 3 derivations. Okay, yang mana basically all the equation ni, tiga equation ni kita derive daripada A is a function of T. Okay, A is a function of T or A is a function of V. Okay, yang ni kita derive daripada A is a function of X. Okay, so normally bila kita diberi A functions untuk dapatkan velocity or the positions, we have to integrate. Okay, to get the V function or the position function to solve the problem. But when we involve with the case of the acceleration is constant, tak perlu nak pening-pening kepala nak integrate lagi. Kita just directly choose any 3 of this to solve the problem. Okay, so this is the equation, the kinematic equation that you can apply when your body or particle is undergo uniformly accelerated rectilinear motions. Okay, this is the 2 common type of motions that can be you define for each particle involved in your study. Okay, alright. So bila you dah faham based on the common motion yang ada, then you should be able to apply into this problem yang mana apabila dia melibatkan motion of several particles. Okay, as I said before, motion of several particles will involve with 2 type of motions which are independent motion or dependent motion. So independent motion maksudnya apa? Kita fokus kepada several particle yang lebih daripada satu. Okay, so independent bermaksud dalam satu pergerakan itu melibatkan lebih daripada satu particle. Okay, yang mana partikel ini bergerak dengan berdasarkan dia punya individual particles. Okay, so bila kata independent tu macam mana pula? Dia bergerak in the same line of action. Maksudnya in the same path. Okay, so bila we have in the same path we have several particle, we can analyze as the motion of several particle yang mana kita boleh study dia punya in term of relative motions. Okay, apabila melibatkan independent motions, okay, kita boleh relatekan dengan relative motion. Kita akan tengok lepas ni lah macam mana kita nak study on the relative motions. Okay, and then the second type of motion under several particle ni, you also can define in term of dependent motion. Okay, ini adalah dependent motion. Right? Bila kata dependent motion tu, kalau tadi independent motion, dia bergerak tidak bergantung kepada orang lain. Okay? Tapi kalau dependent motion, pergerakan salah satu body itu bergantung kepada body yang lain. Okay? So, this is the difference between independent and dependent. Alright? Okay. So, now let's we look on what we can do when we are involved with the independent motions of several particles. Okay? Bila kita melibatkan motion of several particles in term of independent motion, kita boleh study about the relative motions. Okay? And relative motion ini bukan hanya untuk independent motion sahaja, dia also can be applied into dependent motions. Okay? Tetapi bila independent motion, this is the thing that we can relate. Ini saja yang kita boleh study. Yang mana kita boleh study in term of relative motions. Okay? So, in order to study about this relative motion, first you have to make sure that all the particles moving along the same line. And then the time should be recorded from the same starting instant. And displacement should be measured from the same origin in the same directions. Okay, so kadang-kadang kita ada a few particles in our problem, but they are not fulfill these requirements. So meaning that you cannot study about these relative motions. Okay, to study the relative motion, you have to make sure that all the particles moving in the same line, all the positions should be recorded from the same starting instant. Okay, and then should be measured from the same origin. Okay, and in the same direction. Baru kita boleh study about relative motions. Okay, so apa itu relative motion? This is something that we measured not from the origin. We measured from the other particles position ataupun particle motions. Okay, for example here, when we are talking about to determine the relative position of B with respect to A, okay, we can calculate it based on XB minus XA. Okay, yang mana ini adalah kita panggil sebagai relative positions. Okay, relative position of B with respect to A. Okay. So ini XB/A ni adalah term kepada relative positions. Kalau XA dan XB ni kita panggil sebagai absolute positions. Okay, mana kita measure directly from the origin. Okay. So again, kalau kita tengok pada formula ini, dia punya formula lebih kurang sama macam kita nak kira displacement. Okay. B minus A. Okay, the way we write this expression also, you have to follow the rules. Okay, yang mana if you're talking about relative position of B with respect to A, so meaning that XB minus XA. Okay, so basically based on these basic equations, we can use it to determine the absolute position value. Okay, we can determine the absolute position value. Okay, so from here, by applying this concept, dx over dt, you can have the velocity equation for relative velocity of B with respect to A. And then you also can have this equation to calculate the relative acceleration of B with respect to A. Okay, so again, relative motion can be used when you define this condition. Okay, particle moving along the same line, yang mana time for each particle has been recorded from the same starting instant, the position has been measured from the same origin, and so on lah. Okay, so this concept can be applied either in independent motion or dependent motions. Okay, ini kita panggil sebagai relative motions. Okay, so under independent, this is the kind of thing that that only you can study. Okay. Now let's look to this example. Okay. All right. So when we when we want to solve a problem, any problem, make sure that you understand the statement first. You understand the problem given. Okay. You should be able to translate all the information into diagram. You should sketch something. Okay. And then you need to know to relate the common equation or motion to each body. Then you can solve the problem. You cannot simply directly solve the problem without doing all the things that I mentioned just now. Okay, so whatever that you see in this figure, contoh yang ni semua kan, it's not given actually. Okay, this is something that we have to translate into diagram. Okay, right now, first bacalah soalan tu secara sekali lalu. Okay, and then we try again read word by word and then translate into diagram. Okay, kita keluarkan as much as we can all the information given and we add up based on the understanding of the overall concept of this study. Okay, so the ball thrown vertically from 12 meter level in elevator shaft with initial velocity of 18 meter per second. At the same instant, on platform elevator passes 5 meter level moving upward at 2 meter per second. So this is the statement. Okay, so this is the statement. Alright. Where dia kata apa? Ball thrown vertically from 12 meter level in elevator shaft with initial velocity of 80 meter per second. So what should we do? Kita tahu this one bola dia baling dalam elevator shaft. So this is our elevator shaft. Okay. And then based on the statement, ball thrown vertically from 12 meter level. Okay, so ini merujuk kepada apa? Merujuk kepada positions. Okay, merujuk kepada position of the ball. Di mana kedudukan dia apabila dia baling bola tu. So this is where from at t equal to 0. So this is the positions of the ball which is equal to y naught is equal to 12 meter. Kenapa dia sebut y naught? Dia baling from 12 meter. So that is the initial positions. Okay. And then dia kata with initial velocity. So ini bola. Initial velocity of 18 meter per second. Kita tahu bila kita sebut pasal baling, kita throw ke atas lah. Vertical. Dia tak sebut vertical lah. Dia sebut vertical dia. Dia sebut vertical kat sini. And dia sebut initial. Bermaksud dia berlaku at t equal to 0. V going upward. V naught is equal to 18 meter per second. Here we have V naught. Kenapa V naught? When t is equal to 0. This is the statement to mention that we are talking about V at t equal to 0. Okay. So from here, itu based on the statement given. Okay, to complete this diagram, what should you do first? kita tahu ini secara ringkasnya based on the statement. When we study about motion, you should know that you have the coordinate axis. Okay, bila study pasal dynamics, kena ada coordinate. Tak kisahlah static or dynamics, you kena define your coordinate axis first. Okay, sebab kita melibatkan directions. So, based on the direction of motion of this ball, dia mainly bergerak in upward directions, right? So, we are assuming that vertically the upward is positive coordinate axis. Okay, right, so then kita tahu kita punya y0 will be positive 12 meter. The initial velocity is positive 18 meter per second. Okay, and then we are talking about ball. Kita baling and then dia tend to free to fall downward. Okay, so maksudnya dia involve dengan free fall conditions. Apabila dia melibatkan free fall condition, automatically dia akan involve dengan apa? Gravity. Tarikan gravity tu menyebabkan dia tend to go downward direction. So, it's not given in the statement, but we know that when it involves with the free fall condition, it will normally involve with the acceleration equal to negative 9.81 meter per second square. How do we know negative? Based on our coordinate axis. Okay, because we assume upward positive. Bila pergerakan itu ke bawah, bermaksud you ada negative value of the accelerations. Okay. Right, so far that all that we have for the ball. Okay. And then at the same instant, pada masa yang sama, open platform elevator passes 5 meter level. Pada masa yang sama ada open platform. Okay, adanya open platform. Okay. So, yang mana y dia sama dengan berapa? Dia punya position dia is equal to y0. E. Ini E untuk elevator. 5 meter. Ini y0 B. Ini V0 B. Okay. At the same instant, open platform elevator passes 5 meter level, moving upward at 2 meter per second. Moving upward. VE equal to 2 meter per second. Dia tak ada initial velocity. Dia tak sebut pun ini adalah initial velocity. Okay. Dia kata dia bergerak dengan kelajuan 2 meter per second. Okay. Alright, so we just put VE. Then from this statement and then from this problem, we do understand that when we are talking about elevator, pergerakan dalam keadaan apa? Bila kita naik lift, kita bergerak dalam keadaan constant speed, right? So here we have constant speed. Okay, bila kata constant speed, AU is equal to 0. Okay. Alright, so from this analysis, okay, this we call as preliminary analysis lah. Alright, we can define that bola ni kita ada dua particle, ball and elevator. Kita consider as two particles lah. Okay. So ini adalah example untuk independent motion sebab ball bergerak sendiri, elevator pun bergerak sendiri. Okay, so this ball can category as what? Kita boleh categoriskan dia sebagai what type of motions? Just now I had introduced you the particle in rectilinear motion commonly can undergo either uniform motions or uniformly accelerated motions. Now for the ball, which one? Uniform motion ataupun uniformly accelerated motions?
Uniform acceleration.
Ha? Kuat sikit?
Uniform accelerate.
Dia kena undergo uniformly accelerated motion. How about elevators? How about elevator? Elevator. Elevator apa? Dia undergo what?
Uniform rectilinear motion.
Uniform rectilinear motion. Okay, sebab ball ni ada constant acceleration. Elevator ada zero accelerations. Okay, So bila you involve dengan zero acceleration, bermaksud your particle undergo uniform motions. And if your particle have constant acceleration, it's undergo uniformly accelerated motions. Okay. So bila kita dah tahu setiap partikel ni jenis-jenis motion dia, dia akan bantu kita daripada segi apa? Pemilihan equation, kinematic equations. Okay. Sebab bila dia melibatkan constant value ni, kita dah tak payah fikir dah nak kena integrate ataupun differentiate. Kita just pilih the appropriate kinematic equation to be used in the solutions. Okay. Now, bila kita dah identify all the related informations, next kita nak tengok apa yang kita nak solve dekat sini. We want to determine A, when and where ball hits elevator. Where ni maksudnya di mana. Okay. Why? In term of position. When is time. Okay, when is time. T, dia nak T, and where, the positions. Why. Okay. And then, next, relative velocity of ball and elevator at contact. Yang ni when and where ball hit elevator. Bermaksud dia nak apabila ball hit the elevator. Okay, berapa dia punya kedudukan dia and pada waktu bila. Okay. And then relative velocity of ball and elevator at contact at the same position. Berapa velocity dia? Okay. Berapa velocity dia? Okay. This relative velocity of ball and elevator at contact. Bila kata relative, dia between ball and elevator. Okay. Positions of the velocity of ball minus with the velocity of elevator. Where we can write as VB/E. Okay. So this is something that we need to highlight first before we can proceed to the detailed solutions. Okay, once we clear about this part, then we go to here. Okay, but I will not follow these solutions. Okay, sebab solutions ni something that yang dia tahu apa yang dia nak. Sekarang kita tak tahu. We need to follow based on the basic concept. Based on the question needs, okay? Yang mana kita nak dapatkan ni. Kita nak where and when ball hit the elevator. Can you see? Okay. We as an engineer, bila solve a problem, kita sentiasa kena sketch. Kita nak tahu the exact dia punya situation or condition dia bagaimana. Okay, so this is the condition when ball hit the elevator. When you draw this, you will see that the position of YB and YE equal. Okay, apabila ball in contact dengan elevator, bermaksud dia berada di kedudukan yang sama. YB equal to YE. Okay. So kita tahu secara overallnya, the position in contact is YB equal to YE. But the question is, what is YB and what is YE? Itu yang kita nak kena jawab. Okay. And then masuk bila dia kan? In contact. Okay. So to calculate YB and YE, macam mana kita nak dapatkan position of B and position of E? So position of B and position of E can be calculated using kinematic equation. Okay, yang kita terangkan tadi ni, kita ada single equation under uniform motion. Kita ada 3 equation under uniformly accelerated motions. Okay, so when we talk about elevator under uniform motions, right? So meaning that we have only these equations to define the position of the elevator. So kita keluarkan lah. Okay, apa equation dia? YE equal to YE initial plus VE multiplied with T. So this is the only equation that we can use to study about elevator. Okay, this is the only kinematic equation that we have to study about elevator. Okay. However, for the ball, it's undergo the uniformly accelerated motions. It has 3 kinematic equations. So you have to select the best one. So which equation that we can use to study about the positions of the ball here? So kita nak pilih, kita tengoklah yang ada variable positions. Yang mana satu? Sini tak ada. Sini ada positions, sini ada positions. Okay. So which one that we want to use? Because the next question asks you about time t, right? So we will select the second equations in this problem. Okay, by selecting these equations, okay, then we will have YB equation equal to YB naught plus VB naught multiplied with T plus half AT square. Okay, so basically we know to calculate YE or YB, we can use these two equations. Okay, so we can calculate the YB and YE by using these two equations. Okay, now based on these two equations, kita calculate lah. Okay, kita substitute lah all the information, all the data that we have. Okay, so untuk E, initially untuk elevator yang kita diberi, kita hanya diberi YE initial equal to 5 meter dengan VE equal to 2 meter per second. Untuk bola, ball, we are given initial equal to 20 meter. Okay. And then we are given the initial velocity equal to what tadi? Sorry, Y not 12, initial 18. Okay, not 20. So ini 12 meter, ini 18 meter per second. Ini 12 meter. And then we also define A is equal to negative 9.1 meter per second square. So based on this given value, okay, we substitute into these equations. Okay, when we substitute, you will define that we don't have value of T. Okay, kita tak ada value T untuk diganti masuk dalam equation ini. Okay, so bermaksud to get YB and YE, we have to calculate T first. Okay, we have to calculate T first. But how can we calculate T? How can we calculate T? So to calculate T, kita kena work with ball. Kita kena bekerja dengan ball ataupun kita kena bekerja kedua-duanya sekali. Bergantunglah, okay? Sebabnya dekat under elevator kita ada satu equation saja. Now let's we look to the ball. Dekat ball kita tahu kita ada 3 equation. Okay, kita ada 3 equation. Alright, kita ada V is equal to V naught plus AT. Kita ada yang ini, kita ada yang ini. So kita punya mission sekarang nak kira time T. So we cannot select the third one. So we have an option either the first or second. Second tadi dah tak boleh. Kita dah guna untuk dapatkan position. Tadi nah we look at the first one. Pun tak boleh. Sebab tak boleh sebab kita tak ada velocity V ni. Kita tak ada final velocity. So how can we calculate the position right now? Okay, so now we have to look back to what we have right now. Yang mana kita ada YE and YB equations. Where based on this equation, we see that YB minus YE will be equal to 0. Okay. YB minus YE is equal to 0. Where this expression is actually expression for the relative position equations. Okay. Where from here, okay, you can be able to calculate time T. How? We substitute YB function. We substitute YE function. You can develop another equations here. Okay, another equation, but in terms of relative position. Ini tadi in terms of absolute position E, in terms of absolute position B. Okay, now we get T value in terms of relative position. Boleh tak guna? Boleh sebab sekarang ni kedua-duanya bergerak di direction yang sama, di path yang sama. Okay, so by using this concept, these equations, okay, then we substitute the equation for YB, we substitute equation for YE, then you can develop one equation which is in terms of quadratic equations. Okay, So from here, we solve mathematically, then you will get two value of t. One negative, another one positive. So definitely untuk time tak ada masa negative, so kita select the positive value. Okay, once we get the result, then you can answer for YE and YB. Okay, so ganti masuklah nilai T ke dalam equation YE and equation YB. Okay, so for the first problem, for the first question, you can give the answer either based on YE or YB because YE equal to YB. Okay, and then solve lah for the first question. And then for the second question, they are talking about relative velocity. Okay, yang mana VB with respect to VE that can be calculated based on VB minus VE. So this is the VB. Okay, mana kita dapat VB? Again, B is about bola. So under ball, kita ada 3 equation to be used to calculate the velocity. Either you use the first one or the last one. Okay, nak guna the first or the second or the last one. Because we already have 10 key value, right? Then we can choose the first one. Okay, disebabkan dia melibatkan relative velocity. Okay, the second value yang kita ada adalah VE, tak ada equation. VE adalah constant velocity. So dia tak ada function apa-apa. That's why you can see here in these solutions. Ini adalah VE. Sorry, ini adalah VB. Ini adalah VE sebab VE adalah constant value. Okay. So for VE, we calculate based on the first kinematic equations. VE tak melibatkan apa-apa equation sebab dia adalah constant velocity. Okay. And then now from here we substitute T equal to 3.65. We simplify this equation, then you will have this new equations here, then you solve it, then you will get this value. Okay. So dapat negative sign. Betul ke negative sign? Betul ke negative sign? Betul lah. Okay, pergerakan dia akan ke bawah. VB with respect to EB, bola akan directed to downward directions. Okay. Alright, so that is how we apply the concept of relative equations. Okay, in this problem. Okay, ada soalan for this one? Any question for this? Ada soalan?
No question, madam.
Okay, so far good? Okay. Alright, itu untuk applications of relative motion equations. Okay, as I said, it can be applied sama ada in terms of independent motion or dependent motions. Okay, so sekarang ni kita nak tengok pula apabila berlakunya dependent motions. Kalau tadi independent motion, kita hanya boleh study about the relative motion sahaja. Okay, but for the dependent motion, dia sama juga macam problem-problem sebelum ni. Okay, yang mana bila kata dependent motions, okay, satu you kena faham dependent motion tu maksudnya apa? The positions or the velocity or the acceleration depends on the other particles. Okay, pergerakan dia bergantung kepada particles yang lain. Itu dinamakan sebagai dependent motions. Apabila you punya problem tu melibatkan dependent motion, okay, before we can directly solve the problem by using any kinematic equations, dia kena start dengan develop dependent motion equation first. Okay, you have to start the solution with developing the dependent motion equations. Okay, kalau untuk independent motion tadi, dia tak ada specific motion yang kena develop. Kita cuma boleh study berkaitan dengan relative motion sahaja. Tapi untuk dependent motion problem, to solve the problem that involve with this type of situations, you kena start dengan derive dependent motion equation first. Okay. Alright, so to derive these dependent motion equations, okay, dia rely on the calculate the total length of the cord. Okay, ini yang dipanggil sebagai dependent motions yang mana A and B ni dia connected by this cable. Okay, so apabila A ni bergerak, B pun bergerak. Okay, kalau macam independent, kalau A bergerak tak semestinya B bergerak. Okay, but for dependent, A bergerak, B bergerak. Okay. But to derive the dependent motion equation, kita start dengan position equation first. That is the key equation that need to be developed. Okay, the key equation yang kita kena develop adalah position equation. Okay, yang mana later on for the velocity and the acceleration kita just differentiate sahaja. Okay, konsep dia differentiate sahajalah, tapi dia punya just translate sahaja kepada velocity and acceleration term. Okay, so macam mana kita nak develop this function ini yang kita nak develop sekarang ni? How can we develop this? Alright, so as I said tadi, kita nak develop yang ini dia bergantung kepada sum of length of segment. Dia bergantung kepada sum of length of segment. Yang mana dia punya sum of length of the segment must be equal to constant. Okay, sebab kita tahu pergerakan rope ni, dia rope ke kabel ke, kita tahu dia punya total length adalah constant. Dia katakan total length, dia adalah merujuk kepada constant value. Okay, so now to develop this equation, we base on the length of this segment. Length untuk setiap segmen ni untuk menghasilkan kita punya equations. Okay, untuk menghasilkan these equations. Okay, so macam mana ini terhasil? Idea dia again, kita nak dapatkan daripada panjang ni tambah panjang ni tambah panjang ni equal to constant. Okay, alright. So to develop this, you have to follow several procedures. Okay, yang mana pertamanya you kena define the fixed datum first. Find fixed datum. So in this case, kita boleh choose our fixed datum here or here. Kenapa tiba-tiba ada dua tempat pula? Okay. So biasanya kita akan pilih from these positions lah. Okay. Tapi nak mengelakkan you confuse. Okay. Kita akan pilih at this position. Apa yang confuse-nya? Okay. Sebab as I said tadi, dia based on pengiraan length ni tambah length ni tambah length ini akan terhasil lah these equations. Okay. So after you have the datum, okay, next what you need to do is define the the coordinate axis. The positive coordinate axis. Sekarang ni kalau you tengok you punya particle berada below from this datum, right? Now we assuming that going downward is positive. Okay, downward direction is positive. Alright, so bila kita dah ada all these two things, then baru kita go to the next step where we define the position coordinate for each particle. Dapatkan position coordinate untuk particle A and particle B. From this datum or this datum, so this is the coordinate particle A. And then this is the coordinate for particle B. Okay. Now, okay, so for this case from here, alright, when we have this coordinate, apa function coordinate ni? Coordinate ni akan kita guna pakai untuk represent length for each segment here. To represent length for each segment. Okay, alright, now this is the complete diagram that you have. Once you have this diagram, then we can develop these equations. Okay, then we can develop these equations. How? Okay, lepas dah ada semua diagram ni tadi. Okay. Ni datum you. Like ni dia pilih datum kat situ lah. Alright, so kita dapatkan length ni. Berapa length ni? Macam yang cakap, length ini bergantung kepada position coordinate of this particle. But length sekarang ni, kabel ni attached at particle A. Okay, so bermaksud dia akan relate dengan position XA. Okay. And then as you can see, cuma ada satu segmen sahaja yang attached dengan particle A. So meaning that you cuma ada XA sahaja. Okay. Then we go to particle B. Okay. So particle B ni sebenarnya dia akan represent dekat puli ni lah. Ni sepanjang ni adalah you punya particle B. So at particle B here you can see that it has two segment here. Okay. Yang mana these two segment, dia punya length dia is equal to XB. Okay, kalau tengok secara mata kasar, kalau kita pilih datum yang dekat sini, here, alright, ini satu panjang, satu pendek kan? Okay, tetapi sebenarnya we can say that ini equal to this one, yang mana panjang ni kita boleh neglect. Okay. So that's why I said instead of choosing the datum at the very top here, we can choose datum at here. Okay, yang ni pun masih lagi at fixed positions. Okay, yang mana at this part is not necessary. Kalau kita ambil dekat sini, ada isu tak dengan length yang ini? Tak ada masalah. Sebab apabila ada pergerakan untuk partikel A and B ni ke bawah ataupun ke atas, length ini masih remain same length. Tak ada berubah. Okay, so we can neglect it. So we can start measure from this datum. Okay. So tak adalah confused. So yang ini sama panjang dengan yang ini kan. So we can say that for this segment, the length is equivalent to XB. And we have two segments here, right? So meaning that we have 2XB. Okay. So XA plus XB will be equal to total length of the rope. Okay, will be equal total length of the rope. Okay. So this is the equation that has been developed for the position equations for the dependent motions. Okay, so bila kita tengok dekat sini ada XA dan XB, ada dua variable, right? So satu adalah unknown, satu adalah known. Kita panggil sebagai one degree of freedom. Okay, satu mesti known. Okay, maksudnya satu yang kita nak kena cari, lagi satu tu dah kena ada. Alright. Okay, another example. Tadi kita ada dua particle. Now we have 3 particles. Konsep sama. Konsep dia masih sama. Okay, kita ada datum. Okay, we have datum. We have positive coordinate axis. Kita ada position XA. We have position XB. We have position XC. Okay. Now, you can highlight here, we have 2 segments that can be related to position XA. 2 segments that can be related to the position XB. And single segment that can relate to the position XC. Okay. So from here, then we can directly develop the position equations. Kita ada 2XA plus with 2XB plus with 1XC equal to constant. Okay. So when we have these 3 variables, you will have 2 degree of freedom, 2 knowns value and 1 single known value. Okay. So this is how we develop the position equations for dependent motion. Okay, so this is the key equation that you have developed first before we can solve for the velocity and for the accelerations. Okay, once you have these position equations, okay, dia akan reflect kepada velocity equation and acceleration equations. Kalau position equation you salah, definitely nanti velocity dan acceleration pun salah. Okay, how can we get the velocity functions? We just translate X kepada V. 2XA jadi 2VA, 2VB, VC equal to 0. Kenapa equal to 0? Sebab kita konsep differentiate positions. Differentiate variable XA dapat VA. Differentiate variable XB dapat VB. Differentiate variable XC dapat VC. Differentiate constant. Bila kita differentiate value, nilai, nombor, dia akan jadi 0. Okay. And then when we differentiate velocity, we will get the acceleration equations. Okay. So wherever it is, dia bergantung kepada position equation. So you have to make sure you develop the position equation correctly. Okay. Alright. So any questions so far? Ada soalan?
So far, no question.
Okay. So now let's look to this example. Another example. Okay. Kalau tadi everything moving in vertical, now we have one moving in vertical and the other one moving in horizontal. The procedure still remain the same. Tak ada yang berubah. Okay, kita masih lagi nak develop position equations. Okay, dengan by following the same procedure. Okay, tak ada yang berubah. There's no need to define the total length of the chord in X and in Y. Everything should be in one equation. X and 1 should be in the same equations. Okay. So in order to develop these equations, okay, what we have to do is we need to look at the length, what is the value for the particular segment. Okay, what is the position that we can relate to that particular segment. Okay. All right, so now we have vertical B moving in vertical, particle B moving in vertical and particle A moving in horizontal. Okay, so once we know this is about the dependent motion, nampak saja gambar, kita dah tahu dah, oh this is about the dependent motions. Dia akan melibatkan dependent motion equations. Okay, alright. Okay, now for this, okay, kita start dengan apa? Define the datum. Kita ada dua datum for this case. Datum to measure the distance in vertical and datum to measure the distance in horizontal. Okay, so you can have more than two datum. All right. Okay, so once we have datum, then define the coordinate, the position, the coordinate axis. Okay, the coordinate axis for this particle B, we're assuming that everything go downward is positive. For particle A, everything go to the right is positive. Okay, and then we define the position coordinate for each block. Okay, and here we know that, okay, sebab kita kata tadi setiap position ni bantu kita untuk dapatkan length for each segment here. But from this figure, you can see we have this segment. Okay, so as we can see in overall, okay, during the movement, this length remain constant. This length remain in the same length. Dia tak berubah pun. Okay, tapi kalau A and B ni, kalau A ni bergerak ke kanan, length SA ni boleh jadi panjang. Dan length B ni akan jadi pendek. Dia berubah in length punya dimension. Tapi yang kat sini remain in H. So we put H lah, remain in constant value. So we put H ke Z ke, boleh lah to represent that is a constant value. Okay. Alright, so once we have this, alright, next we need to develop the equations. Okay. So to develop the equations, okay. So now here, we will define, yeah.
Nak tanya yang datum dia tu memang kena tengah-tengah kat circle
You kena pilih dekat fixed position.
Oh.
Dekat fixed position. Okay. As I said, boleh pilih dekat sini. Tak ada masalah. Okay. Cuma yang untuk A ni fixed position kan. Ini tak boleh bergerak mana-mana kan. So, kita ambil at this point lah. Untuk yang ini, kita ambil pass through the pulley. Ini kita punya datum. Kena pass through this pulley. At the center of this pulley sebagai kita punya datum. Okay. Alright. Boleh ke? Kalau kita ambil kat sini boleh, tak ada masalah. Nanti you akan confuse, alamak ini panjang, ini pendek. Tapi you akan tengok masihlah guna SB and SB. Okay, sebab dia consider on this part sahaja actually. And the remaining length ni is not considered because they remain with constant value when they in the motion. Okay.
Okay.
Alright. Boleh?
Boleh madam.
Okay.
Thank you.
Alright, so once you have this diagram, then we can proceed to develop these equations. Okay. So kita tengoklah segment by segment. Segment. Ni segment. Okay. Kita dapatkan total length of this chord. To develop this, kita berdasarkan kepada pengiraan total length of the rope or chord. Okay. So untuk length yang ini, okay, kita boleh dapat based on this coordinate value. Okay, which is SB. Ada berapa length yang sama dengan SB ni? Ada 2. So kita write as 2SB. Okay, and then next kita ada this segment. Segment ni berapa dia punya value? H. We put H. And for this segment, berapa length dia? Kita boleh guna based on this expression SA. Equal to what? Equal to total length of the rope. Ataupun kita letak sebagai constant value. Okay, constant. Kita boleh write as constant pun boleh. Kita letak LT pun boleh. Ini bukan satu Kita dah LT. Total length. Okay. So this is how we develop the position equations of these dependent motions. Okay. Once we have this, then we can derive for the velocity equation. How? Kita simplifykan dahulu yang ini. You akan dapat apa? 2VB plus H plus 2VA equal to 0. Okay, yang ni based on what? Kita differentiate dx over dt. Okay, ini konsep dia. We differentiate position equations, we can get velocity equations. Sorry, dia bukan H dah kat sini. Dia jadi apa? Bila you differentiate H, ini value. Contoh, you anggaplah H di 10 ke 20, whatever numbers lah. Bila you differentiate kan dia akan jadi kosong. Differentiate number dapat 0. Okay? So from here, you will get 2VB. Ini bukan 2VA, ini VA saja. Okay? 2VB plus VA equal to 0. Okay. Alright, so from here, we see that 2VB is equal to negative VA. And then from velocity, we differentiate it with respect to time t. Then you can get the acceleration 2AB equal to negative AA. Okay, daripada result ni, apa yang boleh you dapati adalah you boleh check sama ada you punya result tu make sense ataupun tidak. Based on positive and negative sign. Okay, betul ke 2BB must be equal to negative VA? Maksudnya apa? 2BB maksudnya bergerak ke bawah. Positif. Kenapa 2BB kena ke bawah pula? Sebab tadi kita dah assume downward is positive for this particle B. And then kita dah assume tadi ke kanan positif for particle A. Kalau negatif bermaksud VA ni akan bergerak ke kiri. Betul ke tak betul? Make sense ke tak? Make sense? Make sense lah. Bila B ni bergerak ke bawah, dia akan tarik particle A ni to move to the left directions. Okay, that is how we check whether your answer is reasonable or not. Okay, whether it's correct or not. Okay, so this is how we develop the position equations, velocity and accelerations. Okay, any question for this one? Any question? Hmm. Ni. Yes. Betul, tapi initial lah. Dia ada value. Walaupun dia akan jadi 0, what do you mean dia akan jadi 0? Yang ni. Ni. Kenapa dia jadi 0? Sebab you differentiate constant. Betul tak? Lepas tu dia jadi 0. Jangan hafal dia mesti ikut tu. No, dia sebabkan kita differentiate constant. Okay. Lepas tu dia jadi 0. Mencapai ke? Apa soalan yang diberi itu menjawab ke? Okay. Sebab untuk develop position equation ini, okay, kita berdasarkan kepada pengiraan, kita nak kira berapa panjang length ni. Contohnya ini SB tambah SB tambah H tambah SE sama dengan total length of this rock. Kenapa dalam sebutan SB, SE ni? Sebabnya yang ni dia akan berubah apabila berlakunya pergerakan. Tetapi kita tahu dia berubah macam mana sekalipun, dia still lagi sama dengan total length of the rock. Okay, dia masih lagi length dia sama, tak berubah pun. Bergerak macam mana pun total length masih sama. Okay, so that's why kita letak di constant. Alright, so bila kita differentiate constant, dia menghasilkan 0 value. Dia macam 2x plus 3y plus 1 equal to 0. Differentiate 2x dapat berapa? 2. Differentiate 3y dapat apa? 3. Differentiate 1 dapat apa? 0. Itulah contoh dia. Okay. Boleh ke? Differentiation semua ni? Konsep dia. Okay. Bukannya kena hafal mesti equal to 0. No. Because of kita differentiate constant. That's why you got 0 here. Okay. Macam ni juga. Ini constant. Ni constant. Sebab tu kita dapat 0 here. Okay. Right, so this is how we derive, we develop the equation for the position, velocity and accelerations. Okay, yang ini apa pula? Benda yang sama, soalan yang sama, problem yang sama, tetapi dia memilih datum yang berbeza. Okay, they are chosen different position of datum. Okay, dalam kes ni dia ada 3 datum. Okay, dia ada 3 datum. Yang mana first datum here, they are using to define the coordinates for particle B. This datum to show these positions of H. This datum to show the position of A. Ada 3 datum. Okay. Maksudnya untuk B ni, pergerakan dia nak dapatkan positif, kena bergerak ke atas. Kalau dia bergerak ke bawah, maksudnya velocity and acceleration will be in negative. Sama juga dengan A. Kalau A ni bergerak ke kanan, dia akan ada positive velocity. Kalau bergerak ke kiri, dia ada negative velocity. Okay, bergantung kepada kita punya coordinate axis. Ni coordinate axis. Ni coordinate axis. Okay, ni untuk B, upward positif. Yang ni downward positif. Ini ke kanan positif. Okay, bila kita buat solution, make sure that you still follow your assumptions. Okay. Alright, so apa yang berubah? Bila you develop, you will see it has little bit different in terms of the value. But at the end, the results still remain the same. Okay. Alright, now. So, based on this data, okay, kita pun dapatlah kita punya positions. Macam mana? Okay, untuk B, tadi kita measure from here to here. That is our SB. Since that we are choosing our datum at the bottom, so dia bukan lagi dah atas lah, dah kat bawah lah. Kita start from datum to this position of B. So ini you punya SB. Okay. And SA remain the same, H still H. Yang berbezanya untuk position B sahaja. Okay, sebab kita start measure from bottom. Okay, so now kita nak develop position equations. Yang mana again nak dapatkan position equation, ini kita konsep kita berdasarkan kepada pengiraan dapatkan the total length of the rod. Okay. So, kita bergantung kepada length yang ini. 1, 2, 3 dan 4. Okay. So, nak dapatkan total length, dapatkan length ni dulu berapa? Apakah length untuk yang ini? Adakah dia sama dengan SB? Tak, SB panjang dia daripada datum to this point. So, meaning that you tak boleh directly kata length ini sama dengan SB. No. Okay. So how can we get this length? So we can calculate based on the total length of this rock minus with this position of B. Okay, which is it will give you H minus SB. Okay, H minus SB. So kita ada berapa segmen kat sini? Ada 2 segmen. So meaning that we have 2 multiply with H minus SB. Okay, can you see the difference now? Okay, tadi directly relate dengan SB sebab memang dia gambar dia as you can see here. Kan? Nampak tak? Ni ha. Boleh directly relate kan length ni sama dengan SB. But now tak boleh. SB ni kat bawah. Okay. And then plus H still lagi remain H kat sini and then plus SA equal to LT. Ini L bukan 1. Ini LT. Total length. Okay. And then, itulah dia kita punya equation for the positions. Okay. Which is, to get the velocity equation, what should we do? Kita differentiate lah. Okay, konsep dia kita kena differentiate. Okay, how can we differentiate it? We need to simplify this one first. You akan ada 2H minus 2SB plus H plus SA equal to LT. Yang ni, dia dapat 3H. Okay, 3H minus 2SB plus SA equal to LT. Okay. Alright, so now from here, okay, baru kita boleh buat differentiation. Okay, bila kita differentiate 3H dapat apa? dx over dt. Okay. dx over dt. Apa ni? Okay, dx over dt equal to what? Differentiate 3h dapat apa? 0. Differentiate negative 2sb dapat negative 2 VB. Good. How about SA? Good. How about LT? 0. Okay, so this is your velocity equations. Okay, yang mana kalau kita simplifykan kat sini dia jadi apa? Negative 2 VB equal to negative VA. Kalau kita simplifykan dia jadi 2 VB equal to VA. Okay, lain pula tadi 2 VB equal to negative VA. Just now I said the result should be remain the same, right? Sebenarnya samalah jawapan dia. Betul tak betul? Walaupun tak ada negative sign tu, tapi kalau you check balik kepada you punya gambar rajah sekarang. Nah, kita tengok. Dia kata 2 VB equal to VA. Kalau 2 VB bermaksud pergerakan VB tu ke mana? Ke atas ke bawah? Based on this result.
Bawah.
Ke bawah?
Atas.
Ke atas? Ha? Atas ke bawah ni? Ha? Mana?
Bawah.
Bawah ke atas? Result dia 2 VB equal to VA. Maksudnya 2 VB. 2 positive 2 VB. VB tu sepatutnya V ni sekarang bergerak ke atas ke bawah?
VB ke atas.
Ke atas, sure.
Atas.
Ke atas, betul. Jawapan dia ke atas lah. Sebab tadi kita assume apa? Ke atas. VA positif. Gerak ke mana?
Ke kanan.
Ke kanan. Make sense tak jawapan ni? Make sense, betul tak? Apabila VA ke kanan, VB ke apa jadi? Dia mesti bergerak ke atas atau ke bawah? Ke atas. So, maksudnya jawapan dia betul tak betul? Jawapan dia betul. Okay. Kalau VA ni ke kiri, VB akan ke bawah. Alright, so you have to make sure that you relatekan balik kepada you punya assumption yang tadi based on you punya position, position axis you ni, coordinate axis. Alright, so tak kisahlah datum you di mana, jawapan dia tetap masih sama. Okay, alright, so that's all. How can we derive this position equations? Okay, then later on we can get the velocity equation and then the acceleration equations. Yang mana you have to follow this procedure. Okay, kena start dengan apa? Define the position coordinate from the fixed datum lines. Okay, maksudnya kita kena ada datum kita dahulu, baru kita boleh dapat position coordinates. Okay. Tadi kita dah tunjuk yang mana kita ada, we can choose different datum line for each particle. Okay. And then kita relatekan the position coordinate to the chord length. Okay, daripada the position coordinate itulah kita represent sebagai kita punya chord length. Okay, and then segment of the chord do not change in length during the motion may be left out. Macam yang tadi lah. Yang ni, ni tak masuk, ni tak masuk. Okay, so that's why kita boleh pilih datum kat sini. Alright. And if a system contain more than one chord. Okay, kalau tengok example ini semua melibatkan satu chord saja. Satu chord saja. Okay, that's why kita ada satu equations of position. Okay. But if the system contain more than one chord, kita tak ada lagi example yang ini. Apa perlu kita buat? Relate the position of a point and one chord to a point on another chord. So you will start with separate equation for each chord first. Okay, kalau you dapati dalam problem tu melibatkan more than one chord, you kena start with derive the equation of the position for each chord. And then later on kita akan combinekan dia menjadi satu equations. Then baru kita differentiate untuk dapatkan velocities and accelerations. Don't forget to keep track of sign. Okay, so this is the procedure that you have to follow when you define that your problem involving with dependent motion. Okay, when it involves with dependent motion. Okay, now let's we go through to the example that involve with two chord. Yang ni melibatkan single chord lagi. Ni masih lagi single chord Masih lagi single chord. So I tak go through dengan example ni, sama je. You can refer from the previous example. Now I would like to jump to this example. Okay, so this example dia melibatkan two chords. Okay, it involve with two chords. Alright, so what should we do now? The process still remain the same, but we will have at the starting point tu dengan dua equations. Okay, you can see here we have one chord and then this is another chord. Okay, this is the second chord. Ada dua chord lah. Okay, so we know that for the dependent motion, we start with derive the position equations, yang mana kita kena start dulu dengan apa? Define the term first, fix the term line. Okay, and then kita dapatkan positions for each particle. Kita ada XA, kita ada XC, dan kita ada XB. Okay, so this is the position for point A, point C, and point B. Okay, yang point B ni kita boleh cut off dekat sini je. Okay, boleh cut off dekat situ saja. Sebab yang ni, dia boleh represent dekat sini lah, point B. Okay, so this for XB. Alright. So from here, then we can develop the position equation. So this is what we have just now. Okay. Datum, positions. And positive coordinate exists. Downward is positive. Okay, so kita ada positive SA, positive SC, positive SB. Okay. Kalau you assume upward positive, ni akan jadi negatif. Ni semua akan jadi negatif. Ni semua akan jadi negatif. Okay. That's the reason why we choose downward, sebab kita nak dapatkan positive position coordinate. Alright. So when you have that, then we develop these two equations. Okay. So let's we look one by one here. For the first chord. Okay. Kita ada first ni, this length. Yang mana length ni can be represented by SA. So kita ada SA. And then kita ada these two segment. Yang mana these two segment, dia punya length can be represented by SC. So kita ada 2SC. So by adding SA plus 2SC, you dapat total length for the first chord. Okay, length for the first chord. Alright, and then we do the same thing for the second chord. Kita ada this length. Length ni sama dengan berapa? Adakah dia sama dengan SB? Sama dengan SB pun bukan, sama dengan SC pun bukan. But we can calculate this length. Dengan apa? By calculating based on SB minus dengan SC. Kita ada this length and then kita ada another length here. Which is this length is equivalent to SB. So kita ada SB. Equal to total length for chord number 2. Okay. Right, so once we have these two, next what? Okay, next terjadikan dia satu equation sahaja, satu position equation. How we need to eliminate one of the variable. Kita ada variable XB, kita ada variable SA, kita ada SC, kita ada SB. Okay, variable mana yang kita nak kena eliminate? Kita eliminate yang mana dia berada di kedua-dua equation, which is here we have SC at chord 1, itu juga ada SC at chord 2. So kita akan eliminate this variable. Okay, yang mana bila kita eliminate, you akan dapat this single equations. Okay, bermaksud equation 1 minus equation 2. Minus ataupun add lah, ikutlah bergantung kepada value of SC tu. Okay, yang mana kalau kita tengok kat sini, kita kena kembangkan dulu untuk equation for chord number 2. Okay, so here you will have SB plus SB plus SB minus SC equal to L2. So here you will have 2SB minus, ni SC minus SC equal to L2. Okay, so meaning that you have to multiply this one with 2 first. Sebab kat atas ni kita ada 2 SC. Okay, then baru you boleh buat this subtraction. Equation 1 minus equation 2 terhasil lah these third equations. Ni equation 1, ni equation 2. Okay, eliminating SC between the two equation, we get SA equal to 4SB equal to L1 plus 2L2. Okay, so this is the equation of the position that we need to use to define the velocity equations. And then later on we can use to get the acceleration equations. But for this problem, the question asks you to determine the speed of block B. So meaning that kita stop kita punya equation up to the velocity equations only. Okay, so from here we have this. When we differentiate SA, we get VA, differentiate 4SB, we have 4VB, differentiate this total length, we get equal to 0. Okay, so kita dah dapatkan VB kan, so we rearrange this equation, we get VB equal to negative 0.25 VA, where we are given VA equal to 2 meter per second. So we substitute into this equation and finally we get VB equal to negative 0.5 meter per second. Is it correct or not negative sign here? Tengok balik kepada kita punya position axis kita, coordinate axis kita. Okay, kalau negatif bermaksud VB ni bergerak ke atas, betul ke? Betul lah. Sebab dia kata apa? Dekat point A ni kita tarik ke bawah. Bila tarik ke bawah, what happen to B? Dia akan bergerak ke atas. Yang mana dia punya nilai should be negative value. Okay. So far so good. Ada soalan for this one? Any question? Ada soalan ke? Okay. So if I have no question, so this is how you need to do bila dia involve dengan two chord. Okay. Alright, next. We have this example. Example ni pun sama macam example yang mula-mula I tunjuk. Okay. Yang ni melibatkan single chord. Okay, you akan start dengan derive single chord equations, positions, and then you derive, you differentiate it to get the velocity. Okay, then you can substitute all the given value, terjawablah soalan. So soalan you. Okay, formula, the procedure masih sama. Cari datum, find the position for each particles, and then you can derive for the equations. Okay, now this one, sample problem 11.7. Okay, for this sample problem, this is kind of problem yang melibatkan semua. Okay, yang melibatkan semua tu maksudnya apa? Melibatkan semua kinematic equation yang kita dah belajar sebelum ni. Okay. Kalau tadi kita just fokus kepada development of the position equations, velocity equations and acceleration equation for the dependent motions. Okay, so this is another dependent motion problem yang mana sekarang ni dia akan involve dengan different type of motion for each particle. Okay, setiap particle ni dia ada dia punya own motion. Alright. Okay, so now read the statement first. It said what? Pulley D is attached to a cola which is pulled down at 75 millimeter per second. And at t equal to 0, cola A start moving down from K, which constant acceleration and 0 initial velocity. Knowing that velocity of cola A is 300 millimeter per second as it passes L, determine the change in elevation, velocity, and acceleration of block B when block A is at L. Okay, so when we read the overall statement and the question, daripada gambar ni pun kita dah tahu yang mana B ni adalah dependent motion lah. Dia depend kepada pergerakan A dan D. Okay. Now kita nak tahu pula motion for particle A and motion for particle D. How can we know based on the statement given? Again, we read slowly, one by one. We see that pulley D yang ini, okay, pulley D yang ini is attached to a collar which is pulled down at 75 millimeter per second. Pulled down with the velocity Vd equal to 75 millimeter per second. Okay, dia tak cakap pun initial velocity or what. Dia tak cakap pun at t equal to 0, no. Bermaksud Vd ni adalah constant. Ini adalah constant. Bila constant maksudnya apa? Pulley D ni, A dia sama dengan apa? Apabila V constant, A sama dengan apa?
Zero.
A will be equal to 0 value. Okay? So, you should know this one. Dah sepatutnya dah dekat fingertips you. Bila kata V constant dia, automatically A will be equal to 0. So, maksudnya pulley D ni, dia undergo what type of motion? Motion apa? Kita boleh kategorikan dia sebagai motion apa? Apa? Uniform motion.
motion.
Yes, we can categorize as uniform motions. Okay? As uniform motion. Okay? Okay, dan kita baca lagi. Sebab kita nak tahukan untuk A ni pula. At t equal to 0, polar A start moving down from K with constant acceleration. A constant. And 0 initial velocity. Okay? Maksudnya apa? Polar A ni dia undergo what type of motion? Apa dia? At t equal to 0, polar A start moving down from K with constant acceleration and 0 initial velocity. Kita baca lagi. Knowing that velocity of polar A is 300 millimeter per second as it passes L. Bila dia passes dekat L ni, V is equal to 300 millimeter per second. Okay, so now overall, polar A ni dia undergo what type of motions?
Uniform accelerated.
Uniformly accelerated motion. A constant and then ada change in velocity. Okay, so bermaksud dia undergo uniformly accelerated motion. Okay, so soalan dia determine change in elevation. Change in elevation maksudnya dia nak apa? Maksudnya dia nak apa? Change in elevation ni?
Position.
Ha? Dia nak apa? Jarak apa? Jarak daripada initial ke final, right? Ataupun kita panggil sebagai displacement lah. Daripada XB kepada XB note. Dia nak result ni. Dia nak result of XB minus XB note. And then dia nak velocity. Dia nak VB. And then dia nak apa? Dia nak accelerations. AB. Okay, dia nak determine the change in elevations, determine the velocity and acceleration of block B when block A is at L. Bila A ni berada dekat L, carilah dia punya change in elevation, carilah dia punya velocity dan carilah acceleration of the block B. Okay, so that is the overall information that you need to get first before we can proceed to the solutions. Okay, so overall we know that this problem involved with dependent motions. And then we know the next step that we have to do is you have to develop the position equation of these dependent motions. But before we can proceed, based on the statement given, you know that each of the particle involved in this problem, they go through with different type of motions. which is dia akan go through under uniform motions or uniformly accelerated motion. Okay, bila kita dah tahu all this information, later on kita tahu dia akan melibatkan specific kinematic equation for each particle. Okay, so we don't have enough time to discuss in detail how can we solve it. Okay, so never mind. What you can do is I want you to go through with this example first. Okay, yang mana I will show you the step of the solution that you have to do. Okay, jangan follow yang ini. Okay, step dia adalah dengan you pergi kepada slide yang ke-27 dahulu. Okay, the solution should start with this one first. Define the position equation. Okay, find the position equation. Okay, from this position equation, you will see it little bit different on what we have done before. Okay, disebabkan soalan tadi dia perlukan jawapan dalam sebutan yang ini. Okay, instead of we equip equal to total length, we express in terms of initial total length here. Okay, alright, so you can have this kind of equations yang mana you will define that yang ni you ada nilai, yang ni you tak ada tetapi boleh cari, yang ini yang nak diselesaikan. Okay, at the moment you don't have this one, so the next step is you have to calculate this value. This is the second step. But the second step will involve with this equation to develop xd minus xd naught. But again, in this problem, you don't have t value. So the next step is you have to go to the next slide here, where you need to get t value by using these equations. But in order to solve the t value by using this equation, you don't have a. So to get a, you have to go to these equations. Okay, then you will get a. Then you go back balik kepada ketiga, you get t, and then you go to the second step tadi, you will get this equation, this value. Then you can go to the first equation to solve for this one. Okay, I cerita dia punya flow then you study by your own. And then next, you can solve for the velocity. After you differentiate this position, you get the velocity value. And then you differentiate this velocity, you get the acceleration function, then you can solve for the acceleration value. Okay, so that is the flow. How can you solve the problem? You have to study by your own for this one. Okay, because you need to solve for this problem. Problem 11.15, problem 11.59, and then problem past year question. Okay, because we will discuss the solution for during the next class. Okay, so at the meantime, if you have a problem to study about this sample problem, please feel free to ask me in the group, in the WhatsApp group. Okay, so this is another example that you can study. Okay, we have a lot of example here, but I would like to focus more on the exercise. Okay, you can follow this example to solve for this tutorial question. Okay, so that's all for today. Thank you very much. All right, if you have any question, tolong feel free to contact me in the WhatsApp group. Don't ask me individually. Okay, tanya I dalam group supaya semua orang pun boleh tahu apa masalah dia. Okay, kadang-kadang kawan you ni tak tahu apa yang dia tak tahu. Okay, so that's all for today. Thank you very much. Okay, so see you on Thursday. Bye-bye. Assalamualaikum.
Madam,
Thank you.
untuk kelas ganti tu kalau kita buat pukul 10 boleh ke? Saya ada kelas sebelum tu, tadi mic problem, tak sempat nak cakap.
Yang lain macam mana?
Buat Jumaat minggu ni lah, madam. Tak, kalau Jumaat minggu ni kita orang ada kelas ganti sampai pukul 10. Structure.
So, lepas tu pukul 10 lah. Oh, tak boleh. I kena kasih taklimat kepada pelajar baru. Pada pukul 9.45 tu. Melainkan we can do at 10:30. Is it 10:30 okay? Semua orang macam mana 10:30?
Boleh.
10:30 boleh?
Boleh, madam.
Okay, kalau macam tu. Okay, so you can study for this one. Okay, then I will explain to you this Thursday about this sample problem. How can we solve this sample problem? Then you can try to solve anything yang you rasa you faham lah. Okay. Alright, so kita akan ada kelas ganti this Friday from 10:30 to 11:30. Alright, see you. Bye-bye. Assalamualaikum.
Thank you, madam.
Thank you,
Okay, thank
madam.
you.
Alamak.